To solve a status efficiency question, let's consider each statement separately first, then together if necessary. Before we look at the statements, let's remember what a multiple is. A multiple of 30 has to contain the prime factors of 30, which are 2, 3, and 5. So we're going to kind of keep that in the back of our minds as we look at the statements. Statement 1 tells us that A is a multiple of 20. Let's try some test values and see what that means about A being a multiple of 30. Let's start with the value A equals 20, which definitely is a multiple of 20, but clearly not a multiple of 30. Now, what if we let A equal 60? That satisfies the condition that A is a multiple of 20, but this time it's also a multiple of 30, so we can answer yes. So, since we can't definitively answer that yes or no for A being a multiple of 30, this statement alone is not sufficient. So we can eliminate choices A and D. That means the correct answer choice has to be either choice B, C, or E. Now let's look at statement 2. Statement 2 says the square root of A is a multiple of 24. That means that for some positive integer n, the square root of A has to equal 24 times n, which means if we square both sides, that A is going to be equal to 24n, whole thing squared. Doing a little more simplifying by factoring 24, that's going to be A is equal to 2 cubed times 3 times n, whole thing squared. In order for A to be divisible by 30, n needs to be a multiple of 5, because as we said, in order for A to be a multiple of 30, we need the factors 2, 3, and 5. The 2 is already accounted for, so is the 3, which means n has to be a factor of 5. Well, we don't know what n is, so it seems that statement 2 alone is also not going to be sufficient. If we weren't sure how to go about statement 2, we could have also done test values like we did for statement 1. So this time, let's just look at that with test values. So what if n is equal to 1? Then that would mean our A value would be 24 times 1 is 24 squared is 576, which is clearly not a multiple of 30. So the answer is no. Now let's try another value. Well, what if n is 5? Then 24 times 5 is going to be 120, and this might require some multiplication on your part, but our A value is going to end up being 120 squared, which is 14,400, which it turns out, and we can figure this out by factors, that yes, that is a multiple of 30. So once again, we get different results depending on the n values, so statement 2 is not sufficient, which means we can eliminate answer choice B. So the correct answer has to be choice C or E. Now we need to take the statements together. Well, from statement 1, we know that A will have at least the prime factors of 2 and 5. Similarly, from statement 2, A will have at least the prime factors 2 and 3. Putting those together, we will at least have prime factors 2, 3, and 5, which is all that's necessary to be a multiple of 30. Therefore, the statements together are sufficient. So we're pretty happy about that, which means we can actually answer the question by taking the two statements together. So we can eliminate choice E, and the correct answer is choice C. Both statements together are sufficient, but neither statement alone is sufficient.